Hey guys, my name is AP, and today what we're going to be doing is we're going to be adding some rendering to our window. Now, what we did for the last 3 tutorials, we basically are trying to complete the entire window class, so we don't have to touch it, and we can go on to the actual important stuff like rendering, storing stuff in the memory, and doing all that thing. So what we have here is input, the game loop, and creating a window. So to finish off this window class, we also need to before we start getting the tutorial, I created the stop method. It just runs glfw.glfw terminate, which just in case the window is not responding, it terminates it and it's fine. So window.close, and it will return if it wants to be closed, and it will get out of this loop and it will stop it even though it's not responding. So what we're doing now, what we're going to be doing is we are going to add rendering to our window. So right now, if we have a window and it's just black, nothing can be rendered on this either because we haven't made the window renderable, if that's a word. So what we need to do in the create is we need to add 2 lines code. So the first one is glfw.glfw make context current, which tells which window it should render on, and gl create capabilities, which creates the ability to render the window. And I'm going to add some extra code here so we can control it from outside the window class. I'm going to add a private vector 3f, and a vector is just 3 floats, and it stores in one object, and it also can do some math like add, it also has a velocity, and we can just store 3 float values in it. So vector 3f background color, because colors RGB is a 3 float value. So import that. Since this is why I wanted Java Open Math Library from the first tutorial, so I can skip having to create vector 3f class. Okay, so now we need to go down to update, and we need to do, actually, let's do a set background color. So let's go all the way down and do public set, void set background color. And it's going to take in 3 float values, R, a float G, and a float B. And it's going to do background color equals new vector 3f, and it's R, G, and B. So I'm also going to say if that function isn't run, we're just going to make a default in the window constructor. It's just going to set it to black, which is 000. So background color equals new vector 3f, 0.0f, 0.0f, and 0.0f. And just, why do I do that? So now we can go down to the update and actually clear our screen, which is basically why we're making this background color. So we have a color to clear all the pixels to. So first we need to set the background color, which is gl11.gl clear color, and it is asking for RGB. And the last one is alpha. We don't want a transparent background color, so we're just automatically going to set that to 1.0f. I like doing this because it looks better than just 1. And so what this needs to be is background color.x, and we can just copy and paste this into the other 2 and change it to y and z. Now these are actual coordinates. These are just float values, and since they're assuming that you're using it for coordinates, they just put an x, y, z. So the next thing we gotta do is actually clear the screen. So gl11.gl clear, and it's asking for what should be cleared. For right now, we just want the GL color to be color to be cleared, so we do color buffer bit. And for later on, we can actually, if we're using the depth buffer, we might clear that too, but right now we're just using the color buffer, which basically is like two separate images that is rendered onto the screen. So if this should work, we should go to here, we should do window that set background color, and we can do 1.0f, 0.0 and 0.0, and that should make a red background. So let's save that and run. Now, as you can see, we got a red background, and that's all good. But we're not just going to be using set background color. We're also going to be creating models. And so what a model is basically a bunch of vertices to create shapes, simple shapes. Now, the models that you see on computers today, which is like cubes and way more complicated things, they use this system, but it's in a way bigger scale than what we're going to be doing for right now. Sooner or later, we're going to be adding OBJ loader, which loads all the information from OBJ file and loads it onto our screen. So what we're going to do is we're going to create another part of our engine. We're just going to say engine.render. And this is where all our rendering components are going to be. So the first thing we need to create is a model. So model. And so in this model class, we need to create two functions and some getters. But first we need to define some variables. So we need a private int vertex array ID, a vertex buffer ID, and a vertex count. Now I'm going to be explaining what all of these mean. So a vertex array ID is like an array of vertex buffers, and vertex buffers is just a bunch of stored data. So basically it's like a list of, it's like a double array, but after each frame it gets sent to the memory of your computer to be rendered on the screen. So we need to create a constructor public model, and it's going to take in a float array, there we go, and it's going to be called vertices. And let's add one of those things, and we're going to set the we also have to create another variable called vertices, so we can actually store this and use it in our create function. So private float array vertices, and so we do this dot vertices is equal to vertices, you know, the normal thing, but we're going to set the vertex count to vertices divided by dot length, not hash code, dot length divided by 3. So what this basically means is, since it's a three-dimensional rendering display, it's going to need how many vertices there are, and since there's 3 values in a vector, then divided by 3 is get how many vertexes. So we need to create 2 functions. It's going to be public void create and public void remove. And we're also going to get some getters and setters. So let's just do that real quick. Source, get getters and setters. Well, we only need get select getters and not for vertices. We just need it for these 3. And there we go. And so now we have these 3 getters and setters. And now we're going to fill out our create method. So with this, we're going to create a float buffer, and we're going to flip it because GL likes flip buffers for some reason. I don't know the exact reason. You can search that up if you want to. And so we're going to create a float buffer, and it's going to be called buffer, and that's going to be equal to buffer utils dot create float buffer, and the capacity is going to be vertices dot length, so it can store vertices. And so import float buffer. And we also got to put vertices in the buffer. We just got to initialize it before we do that. Vertices. And then we got to flip the buffer. Like I said before, I don't know why. So now we have a buffer for our our vertices. And so now we have to initialize these two IDs. So we're going to do vertex array first. So we do vertex array ID equals gl30.gl gen vertex arrays. And what this does, it makes a vertex array for us, and it's set to this value. So what we got to do is we got to bind vertex array to one of the available vertex arrays. So we're going to do gl30.gl bind vertex array, and we're going to put in vertex array ID. So we're going to do the same thing for vertex buffer ID, but it's going to be in GL15 1.5 instead of 3.0. So we do vertex buffer ID equals GL 1.5 and GL gen buffers instead of vertex arrays. And we are going to bind that buffer with basically the same way and bind buffer, but it's going to take an extra argument, and it's going to tell us what type of buffer it is. So it is going to be GL 1.5.gl vertex. Oh, I might have the debug. I do have the debug. I don't know why I have that. I'm going to probably get rid of it after this. So GL array buffer. And just return and put in our buffer ID. So now that we have binded both of these, we actually got to fill in the data for the buffer ID. So let's do GL 1.5.gl buffer data. And it has three things. So the target is what we put up there, the GL array buffer. The data, which is what we created up here, flipped vertices. So we're going to put in buffer. And the usage is what are we going to use this data for. Now there's a couple of them, but for right now, since we're never going to be changing these, we're going to do static draw. And I'm doing static draw because why wouldn't you static draw? So there we go. And next we got to do is we have to bind this buffer with this vertex array. So how we do that is we do gl20.enable, not gl enable vertex attrib array, and it's taken index, which is the first one, which is 0. And we didn't need to disable it because if we don't disable it, bad things could happen and it could ruin our program. And the next thing we got to do is we got to create a vertex pointer with our buffer data in it. So we do gl20.gl what is it? I'm trying to remember. Yeah, vertex attrib pointer, and it takes in 6 things. The index is what we start at. We're going to start at the first one. The size is how big each vertex is going to be, which is 3, because 3-dimensional. A type is what type these the 3 values are. It's going to be a float, but we can't write float, so we have to do GL 1. Is it 11? Yeah, it's 1.1.gl/float. Then for normalize, we're just going to set all of these to false, but only this one is a boolean, so we set this one to false. We set stride to 0 and pointer to 0. Okay, so now we have to unbind this vertex array, or it might get messed up, but we're not going to unbind this buffer or it won't work at all. So we do gl 30.gl, not 300, gl bind vertex array, and we're going to set it to 0 instead of our vertex array ID. So now we have to fill in our remove function. So the remove function basically gets rid of all the vertex array ID and the vertex buffer ID. So what we need to do then is we need to do gl30.gl delete vertex arrays, and it's going to take in the ID of our array, and gl1.5.gl delete buffers, and it's going to take in the buffer ID. So now our model is done for right now, and so probably next we're probably going to add textures and indices, which is a whole nother I'll explain later. So in the render, we need to create another one called renderer. So basically how we're going to render our stuff. So there we go, renderer. And we're just going to have one function in it for now. It's going to be public void render model. And it's going to take in a model. And we have to it's going to take in the model so we can grab all the information. That's why we got these getters. So the next thing we got to do is we have to bind the array. So gl30.gl bind vertex array, and it's going to take in the model's VAO, or vertex array ID. They're called VAO and VBOs for short. So I'm just going to use the full name because this is probably your first time dealing with this. And then we're actually going to disable it before we do anything, just so we don't forget. Vertex array 0. So now what we're going to do is we're going to draw using all the information. So what we're going to do is we're going to do gl1.1.gl draw arrays. Now what this does is it tells us what it's going to use. So we're going to draw it using triangles. Triangles. It's going to take in where we start at, so 0, and it's going to take how many we have. So it's model.getVertexCount. So now that we have this method done, we should be able to render our first model. So let's go to the main class. Let's create our first model. So since model takes in mod at the beginning, so we're going to do new model. And we're going to make the float array in the, there we go, and then it's going to fill this out. We don't need that. Oh crap, there we go, and get rid of that. Import model, and this is where all our information is going to be. So first we're going to create the top left corner, which is, we're going to actually make a quad with this. This is what I'm talking about, top left. So the top left would be, if it's normal, that means going down is negative and going up is positive. Okay, so if we go to the left, it's negative, so it would be negative 1.5f. Since it's going to be above, so it will be 0.5f, and there's no x coordinate yet, z coordinate, so it's just going to be 0. All the z coordinates are going to be 0 for right now until we get into projections and all that, but that won't be until after, shaders probably. And so we go top left to top right, and top right is just both positive to bottom right, which is only the x is negative, y is negative. So this creates our first triangle. Now I'm going to copy that and put it down here, and we're going to create a second triangle. So it's going to go from bottom right, which is both negative, to bottom left, which is the y is negative, to top left, which is the x is negative. Okay, hopefully this works first time. And so we got that. We're going to do model. We have to create a renderer. So public static render is equal to new renderer. That's a lot of renders. Import renderer. Use our renderer. We don't have to create it. We just gotta run renderer. So render model. And then we have to, after the loop is done, we're gonna remove the model so it doesn't clog up memory later on. So hopefully this creates a white rectangle in the middle of our screen. It didn't. That's totally fine. it might have put all the coordinates in the wrong order. So first of all, let me find what we have to do, like the correct coordinates, because I might not remember those. Okay, I'm back. After a couple minutes, I realized I made a derp. You got to create the model. Stupid of me. Anyways, so actually I changed it to being a triangle, just for testing. It's a lot simpler than a rectangle, and it works now. So I'm gonna change that to a rectangle real quick. Just hold on. Okay, so here are the coordinates for the for the rectangle. So it starts at the top left, which I should probably make some comments to help you guys. Top left, top right, and bottom right. And so down here, this is bottom left, bottom right, and bottom left. And so now it should help you. So top left, top right, bottom left, bottom right. Not bottom, it's top left. So now here's our rectangle with a red background that we can set from our main class. And yeah, so the next tutorial we're going to be adding a texture, and to improve it we're going to also be adding indices. So instead of having to redefine these two vertices right here, we can just delete them, and then with another int array we can define which vertices we want to use. So I hope you enjoyed this tutorial, and I'll see you next time. Bye.